Welcome, ladies and gentlemen. So what we talked about last time is how to sketch a vector, and I kind of erased those because we really only need one example because it's much easier to do this typically, usually algebraically, than it would be by looking kind of at the graph. So I kept our first angle, and what we're going to be doing in this video is how to find the magnitude of a vector. So first of all, if you look at this, we called this vector v, right? And remember, to sketch it in component form, we had our initial point, which is 0, 0, and then our terminal point, which is at 4, 2. But it's not a point, it's a directed line segment, so therefore it goes from here to here, and we have that arrow. So what exactly the magnitude represents? The magnitude represents that distance that we traveled from our initial point to our terminal point. And we represent the magnitude with kind of these double lines outside of v. So we want to know how long is it from the initial point to the terminal point. Now, I left this first one up here because typically, if you look at this, you can see that we can create a right triangle. And by creating a right triangle, we know that we can use the Pythagorean theorem. Now again, remember, we traveled 4 units to the right and 2 units up, right? So basically, how do we find the hypotenuse, which is going to represent our magnitude? Well, using the Pythagorean theorem, you could say a squared plus b squared equals c squared. So you have 4 squared plus 2 squared equals c squared. C squared represents our hypotenuse. 6 plus 4 equals c squared. 20 equals c squared. Then we'll take the square root of both sides. Can't take the square root of 20, so I can break that down into the square root of 4 times 5 equals c. Square root of 4 is 2 times the square root of 5 equals c. So therefore, I can say the magnitude of this vector is 2 square root of 5. Okay? Now, are you always going to want to sketch the angle and then go ahead and create a triangle and then use the Pythagorean theorem? No, because fortunately what you hopefully recognize is it's going to be the same no matter what. We're always going to be basically doing whatever our two components are of our vector. That's what we're going to be using to find the magnitude. So the formula, when we have a vector in component form, looks like this. It goes magnitude of a vector v, or of any vector, is equal to the square root of vector 1 squared plus, component 1 squared plus component 2 squared. So if you remember my previous video, we talked about these as kind of like x and y's. Well, when we're looking at them in component form, we really just talk about them as components of the vector, whereas v1 and v2, which is kind of similar. For graphing, we can think of them as like x and y points. But in component form, we think of them as our components, v1 and v2. So basically, all we simply need to do is use this formula to be able to find the magnitude. And again, the magnitude is going to be the distance from our initial point to our terminal point. So in this next vector, the basic thing I want to do is label my v1 and my v2. And then I'll just plug them into my formula. So I'll do the formula kind of full intact here, and then I'll kind of start streamlining this process. So v1 is, so it's v1 squared plus v2 squared. So now all I'm simply going to do is replace 2 with v1 and replace v2 with 0. So therefore, I have 2 squared plus 0 squared. Well, 2 squared is 4. 0 squared is 0. 4 square root of 4 is 2. So therefore, the magnitude of this vector is just 2. And if you look at this graph, if you remember this one, all it was going to the left. It didn't even create a triangle, right? It was just going 2 units to the left. So what is that distance? It's just 2 units to the left, right? Fairly easy. All right, I'm going to kind of do this one a little bit quicker since we've kind of already known the formula. So I'm just going to immediately plug in my values, v1 and v2. v1 is 3, v2 is negative 5. So let's do 3 squared plus negative 5 squared. And what you'll notice about it, it doesn't even matter if it's negative, because that squared is going to reduce it. Because remember, when you look at the vector, this one was something like this, right? 3, negative 5. So you can see that it's kind of like going down. But again, that's going to be direction. And a vector has a direction. The direction can be positive and negative and so forth. But the magnitude, I want you to understand, the magnitude is always going to be positive. It's that distance from the initial point to the terminal point is always going to be positive. And the reason why it's positive, because it doesn't matter what negatives we have, they're going to be squared. All right, so 3 squared is going to be 9, plus 5 squared is going to be 25. 9 plus 25 is 34. We try to simplify 34 like I did over here in 20, but I cannot find any square numbers that divide into 34, so therefore that's just going to be my final answer. Now, when looking at a linear combination, I like linear combinations. To basically, we could do the same formula with our coefficients of here and here, but hopefully you just remember that from the last video. If I will have a vector written as a linear combination, I can rewrite it quickly as a vector in component form. And therefore, I can see here's my component 1, here's my component 2, square them, add them, take the square root of it. So I'll say, oh yeah, I'm calling these all v's. Because they could be w, they could be x. Like remember the last video I saw this was w and I said that one was z. Well, I kind of forgot about the last video, so I just called them all v's. All right, so this one, magnitude of v, is going to be equal to, let's see, 9 plus 4. 3 squared is 9, 2 squared is 9, or 2 squared is 4. And that gives me the square root of 13, which cannot be simplified, so that's our final answer. This one, if you remember, this was just a vector going straight up. So I didn't even create a triangle. So therefore, I can quickly just say, I don't even need to do my math. The magnitude of this is just 4. And lastly, over here we have 2 negatives. So let's see here. 2 negatives, so I'm going to go, actually I don't need to sketch it. We already sketched it last video. So I'll just do the magnitude of v is equal to negative 2 squared plus negative 1 squared. Remember, there's that negative 1 that's in front. And I wanted to write this one out because a lot of students get this confused. They'll type maybe in their calculator negative 2 squared, and it gives them negative 4, and they'll plug that in. But remember, you got to put parentheses. It's negative 4 times negative 2 times negative 2, which is a positive 4. So just really careful when you're entering that into your calculator. So that's going to be positive 4 plus a positive 1, which equals the square root of 5, which again cannot be simplified. So therefore, that's going to represent our magnitude. So there you go, ladies and gentlemen. That is how you find the magnitude of a vector. Thanks.